A chocolate bar has a stated weight of 200 grams. To avoid complaints, they set their machine to a mean of 204 grams with a standard deviation of 1.5 grams. What is the probability a bar will be underweight? So we're after, first of all, let's state our distribution. We're saying that the weight is normally distributed with a mean of 204 and a variance of 1.5 squared. And then what we're after is the probability of the weight being less than 200. So we know that we have an app on the calculator to do this. So we're going to go for that app. And of course, I can put negative infinity in here, but just put a small number in there. The upper is 200 in this case. And standard deviation was 1.5 and the mean was 204. And that gives me 0.0038 if I go to 4 decimal places. So it's a fairly small probability. To test the settings on the machine, samples are regularly taken and weighed. 1,000 bars are tested over the course of the day, and the distribution below is found, where X is calculated by weight take away 200, rounded to the nearest integer. So in other words, this would be a bar of 200, this one would be 204, and so on. We want to calculate the mean and standard deviation for the data. Now, there are lessons elsewhere showing you how to do that manually. I'm going to do it with a calculator, and most calculators these days have facilities to do this. So I've loaded it into my statistics app, and then I can say one variable, and that's what tells it it's a frequency distribution. And you can see the mean is 4.501. So the mean was 4.501 and the standard deviation was 1.405. Now that would correspond to the mean for a bar being 204.5 and the standard deviation being 1.405. And we're saying that these were the settings that the machine took. So if we assume the data is approximated by a binomial model, does the normal model for the machine settings seem appropriate? Well, that's not that far from 204, and perhaps we would consider that's not too far from 1.5. And we know that if we have a binomial NP, then we do the mean NP and the variance NP1 minus P, and we use those as the parameters for our normal distribution. So on this basis, I'd say that that's probably okay.